This video is sponsored by Control Plane. Previously on CityFast Fresh Deploys with Rust. Sure. So I wanted to kill a tile and then spawn. Yes. We want to build a Rust application in Docker. It already failed. All right, this should be the... No. There we go. We're going to need a Postgres instance locally. Dev up. Gonna let us look inside the Postgres database. Yeah, cool. Finish. It's not going to be graceful shutdown. It's going to be violent shutdown. So yeah, now it's async, everything is async, and we can connect to our database. And I wanted to do that with SQLX. SQLX is a Rust SQL toolkit, which is database agnostic. We don't really care about the agnostic part here. So how do we use SQLX? Well, we read the docs. Okay, and this is going to be read from the database URL. So come on, Copilot. Yes. We have a pool. The query we want to do is, I think Postgres lets you do a create table if not exist. So let's try that. Path and hash text primary key. Data blob not null. Yes, that should work. And then create the revisions table. The point is we want to store every revision of our application in the database. And so we need a row for every file, but we also don't want to upload files again that are already there. What's the primary key? I guess that is the primary key. Yeah, sure. And then, yes, latest revision. So this is a dummy table because this is essentially a global. This is always going to be like latest. Now it's complaining about PG pool options. It wants the thing to be a string slice, not an own string. And we are actually not returning any error type. So we need to use unwrap instead of the question mark. Let's look at their README again. Execute. There we go. Pool. Await. Unwrap. Okay, that works. Type blob does not exist. Huh. Oh, okay. That's byte A. Okay. There we go. Cool. All right. So all migrations applied, which means if we look in the Beaver tables, there we have it. We have files, we have latest revision, we have revision files. It's amazing. So first we want to list all the files. Let's just see what this prints. I mean, that's not bad, right? I'm okay with our revisions having all of these because it's already ignoring target because it's in the git ignore, and the whole point of the ignore crate is to respect files like git ignore. So I don't mind if like we have a .nix in there and this and blah, it's fine. Okay, so the next step is we don't care about directories first of all. Do we have a type? File type. Is file. Okay. Then this is the path, and we want to compute the hash. The hash I'm using for my website is chash. So we got the path, and we want to read the file asynchronously. And then the hash is going to be chash. Hash. Yes. Of the contents. And we're going to format that. U64 is 8 bytes. And then print it. You know what? We're going to normalize the path as like a string. I'm not really planning on using any file which path is not UTF-8, so I want this to crash if we have one. And now what that should do is list all the file and their hashes. Yes. And this is going to be our deploy manifest essentially. But now we have to think about how we are going to do this. We are going to want to run this locally, and this is going to talk to an API, which is going to write to the database, and then the actual web server instances are going to listen from that database. So I want to commit this. Then I want to add something like clap with derive Because this is going to be both the CLI that's going to help us deploy the Fresh app, and also it's going to act as the server. So we're going to have a serve subcommand and we're going to have a deploy subcommand. We're going to derive parser and not debug. We don't really need that. Very nice. So serve is just serve and deploy is just deploy. There we go. Now we can parse the CLI. And don't forget to change in the Docker file the command, which is going to be refresh proxy serve. We want to match on the subcommand. Okay. And then we'll make separate functions. Should probably have a function that returns the pool. They probably have a type alias for that. Yes, they do. Okay. Just gonna run all the migrations. Put it at the end of the file. Deploy walks, all of that. But here's the thing. Most of these are going to be actually serving the Deno app, and one of these is going to be our deploy ingest point. And so we need two different modes. Hi, Editing Amos here. Let me just clarify what's happening here, because it's a point in the video where I'm preparing for a lot of things later on, so they make sense in my mind, but they don't if you're just watching the video. So here's what the final setup kind of looks like. We have the same binary everywhere. We have the binary on my local computer where I'm developing the Fresh app, and we have it in two different workloads. Why do we have two different workloads? Because it's annoying to talk to the production Postgres database from the local computer. It's not impossible. We're going to have it on Amazon, so we could set up Amazon Client VPN, but it's really annoying and I didn't want to spend any time in the video doing that. So we're going to have another workload whose sole job is to accept HTTP requests from our local computer and then write things to the database, and also eventually emit a Postgres notification. All those TCP proxy instances are going to listen to that notification and then read the latest files from there and seamlessly switch to the new version of the Fresh app. And it's ridiculous. There's no reason why we're doing all this except for we can, and that's what I came up with. If we were making an HTTP proxy, we wouldn't need to have a separate workload. We should just have a well-known endpoint here and authenticate it. But I chose to make a TCP proxy, and so I kind of drew myself into a corner where we have to make this separate workload that is going to be an HTTP server, and that's what's going to happen in the next sections of the video. Yeah, I hope this clarified things. This is what we're going for, and nobody's saying it's a good idea, but here we are. So deploy ingest and serve fresh. There we go. Okay, and then we're gonna have a single endpoint, and it's gonna take JSON. I'm gonna write down some types, and hopefully you'll see what's going on. Serialize, deserialize, enum, API call. And then one of them is gonna be list missing files. It is gonna just be a vec of path and hash, but it's actually just a string. So we wanna use those from Serde. Cool. API request and then API response, I guess. Yeah. So this is dirty. It's not really the way you want to design an API, but it'll work fine for us. So here's how it's going to work. Path and hash should be buildable from a disk path. Derive debug on there. So now when we deploy, we just go through all these entries and then we make a path and hash. Yeah, perfect. So if I cargo run now, it's going to fail because it's expecting a subcommand. Okay. So it's to deploy. So deploy finds all these paths and hashes, which is great. But then the next thing we want to do is list missing file. We're going to read that from the environment. And I said this is going to be HTTP, so we're going to need an HTTP client. So yeah, request is fine. Okay, now we're getting the list of missing files. In a perfect world, we wouldn't want to upload all the files in one go. We'd batch that, but the API design here lets us actually do that if we want to do that later, whatever. So this is interesting. It's trying to do map and then await. That's not going to work. It's not going to work because we cannot await from map because map is sync and Tokyo FS read is async, and we can't do that. Also, we should be reusing our client, so let's just make a single client here. It is supposed to upload the files. Okay, assert success, that's cool. And then make a revision. Okay, and it prints the new revision ID. So cargo run this wants deploy ingest address to be set, and then we can't connect to that. So that's fine. But you know, this is what's nice about types. You can code one end of the thing, and now we're gonna code the other end. So we have the client, now we're gonna make the server. So deploy ingest. And we are going to make the server in the next part of the series. By the way, have you noticed that we're using JSON to send binary data? I bet we're gonna have to switch to something else. But what will it be? The suspense is untenable.